So here you can see actually one of the Pathfinder project, ET Pack. Then you have Cassiopeia, Outdoor, You Share My Space, Trust Me, Delaware, and so on. So you can see we do have a lot of projects in space debris and enabling space technologies. So what do we do as portfolio activities? So when you join the EIC, there are various activities, but the program manager, he creates actually project synergies. We build a portfolio plan. We had already the first portfolio meeting. One of my roles is to be your ambassador, to be your facilitator. So I arranged with my colleagues from Pillar 2 to have the IOD, IOV fast-track flight opportunities, introduction to potential investors, participation at events. We had the EU-Japan webinar, which was a bottom-up idea which came from you. And I advise you on technology and commercialization activities. So here are some of our success stories. As you can see already in 2023, there were quite one of our projects was mentioned. There were 5 launches of some of our 2 projects which launched twice, and one of them is also here among us. So let's start with the roadmap. And I want to be fast because I want to hear your pitches, actually. I'm really looking forward to hear your presentations. So one of the questions I always receive is, how did you select what was the way you selected the topics? Well, my knowledge, my experience, but also we do horizon scanning. So there you can see various areas where we do the horizon scanning. I analyze the projects which we have also in-house. And we also closely work with DG Defis from Pillar 2 and the colleagues from HADEA. So actually, they also, the colleagues from DG RTD, they provide the policy guidance aspect. And of course, SRIA. And identify gaps. And the criteria which I use are ambitious science, radically new technology, and these are part of the work program criteria also. But I believe that for space safety, reliability are critical aspects. Risk assessment, what happens if we don't invest? So it's very important to think in the long term, because this is TRL 1 to TRL 4. And of course, technology sovereignty. The other principles, the other criteria, I will not focus, but the portfolio considerations play an important role. And here you would see what is the technology roadmap we have managed to build already, I have managed. So we started with a work program with 2 topics. 2023 in-space solar energy harvesting. We received quite a number of proposals, very interesting, very exciting proposals to collect, convert, and wirelessly power in-space green propulsion, use of solar energy, and then the accelerated customer-driven innovative space application. Now, 2024, we have the Pathfinder, which is space debris mitigation, remediation, and in-space recycling. I believe these topics are very complementary with each other, because you always, they're fitting, and you can always use enabling space technologies, which are from TRL 1 or TRL 4, or if you have low TRL from the accelerator from the previous year, you can fit it in the one for work program 2024. So let's see what we have today. Well, you all very much are aware of the debris situation. I do not need to tell you more about it. Debris with different sizes, uncontrolled debris. There are more than 11,500 tons of debris in December 2023. 85% are uncontrolled, and they're a hazard. But not only space, but they can become a hazard for human population, for air traffic, for naval traffic, and so on. The most populated orbits are between 600 and 800 kilometers. And we have, so as you can see here actually on this graph, there is a report where the projection, what happens even if we stop launching, the amount of space debris will continue to increase. Another aspect, and a critical aspect, is that the satellites are built not to be serviced or easily recycled. There is a high number of explosions in orbit, and a lot of them are due to leftover energy, onboard batteries, and so on. And there are a lot of unknown events, breakup events. Actually, based on some data from ESA DISCO's database, they talked about 35% unidentified causes. And I think among of you, there are colleagues who have even better statistics, understand much better, and know the data much better. But some of the objects which you see, they fall and they survive atmospheric re-entry. So we have to be very aware how to protect our space infrastructure. But also, we do lack the capabilities to service or to recycle debris in space. And as you know, there is an increased cost of space operations. And very soon, many important orbits might become unusable. And we can basically not protect properly our satellites. So we need to, in order to stabilize the space environment and Earth's orbits, particularly the most polluted one, we need to remove 5 to 10 space debris objects. Plus, as most of you know, there are discussions for reducing the time for deorbiting to 5 years, because now it's, I think, 25, and there are discussions that there will be a reduction to 5. So now is the golden time that European companies get together and they actually propose ideas for space debris mitigation and remediation. And we have the technologies. As soon as this regulation comes in, your services could be commercially available. So what is it about? As I mentioned earlier, it's about protecting the EU space infrastructure. But the main challenge which I see is we need green, compact, but affordable deorbiting solution and in-space recycling capabilities. So actually, these are the 3 areas. On the right, you have a drawing for space-based lasers. So when I talk about active debris removal, it's not only active debris, but also propellantless solutions. I think that is very, very important to consider. So you can also think about having concepts for debris mitigation measures integrated already in the design. This is really low TRL level, so TRL 1 to TRL 4. So all ideas are very welcome. So what are the 3 categories? This is in the challenge guide: space debris mitigation, remediation, and in-space recycling, as I mentioned earlier. And here are some concrete examples. In orbit, so for space debris mitigation, in orbit space debris recognition and detection. This is actually, before that, I'll go to the previous slide, because what I wanted to say that these categories, projects can work also together in between each other. And this is the big challenge when you're writing your proposal, because they're very diverse, the different concepts for remediation. They're very diverse, the models. So it will be very difficult, but on the other hand, you would be able to make these connections really easily. So space debris mitigation, you have debris recognition and detection, collision avoidance models. Here you can look at control debris mitigation. I would love to see proposals linked to control debris mitigation. So looking at ideas to reduce the release of debris, safety of spacecraft, safety of spacecraft breakups, debris shielding, but also at the subsystem level. So that's important. Self-disposal, spacecraft passivation, and so on. Other areas which are in the domain of remediation are, of course, when we talk about remediation, I just want to make it very clear, it is the reducing the risk associated with orbital debris by moving it, removing it, or reusing it in one way. So active debris removal, now we have all kinds of robotic arms, magnet nets, harpoons, but you can have physical sweepers in orbit collecting the orbit and recycling. You know, it's all it's Pathfinder, all your imagination is open. But then something which is very important for me is propellantless debris removal concepts, because there you reduce the use of fuel. So I want to have concepts where you can actually either combine or have individual, have tethers, solar concentrators, space-based lasers, laser push light sails, ones which are actually not using so much fuel. And here also you have the ENVISAT. This is a mission of ESA. ENVISAT is one of the examples, inactive since 2012, operating in, I think, an orbit above 700 kilometers. But it would take 150 years for this 8 tons to burn in the atmosphere. So imagine how... So I want you to look at all kinds of cooperative and non-cooperative debris too. Not only cooperative. That's the easy part. The non-cooperative are the tricky one, and I think you all agree with me. Other examples in remediation is here you can see some other projects. I just found them while reading some articles. So you can have tethers in combination with flexible nets. You can have tethers with grippers and robotic arms, but I want different concepts. I'm not asking you concretely. These are just some hypothetical examples, okay? So please use your own imagination. Don't rely on what I have only written or added, okay? In the Pathfinder Challenge Guide, there is a very detailed list of references for documentation, and reading it maybe could give you some additional ideas. So the third category is even a more interesting one. It's a very much long-term one. It is about in-space recycling. And there you can think about mechanical reuse of mechanically, when you have an anomaly during launch, you could be able to repair or recycle or reuse or take parts mechanically, or also space welding, additive manufacturing, seeing how you can take the defunct satellites or upgrade upper rocket stages. You know, there are a lot of discussions about, especially in the US, they look a lot in that domain. So any idea or concept which is demonstrating the reuse of orbital assets will be very much appreciated. And then finally, I come back to the famous 3 categories, which are very much in the domain, as I mentioned already. So here you can have projects which either work with one category and the other category. So you can have a project which designs and developed collision avoidant concepts, or develops a simulation tool for proximity operations or re-entry, which is complementarity to a project proposing active debris, or robotic, or deorbiting mechanism, or something like that, or propellantless, okay? You can also have projects that provide, again, from category 1, because you cannot do active debris removal without category 1, without spacecraft recognition or detection or collision avoidance. So they could collaborate, or category 1 with category 3 about in-space recycling. So diverse projects, for example, from category 3 can be designed to reuse space debris or look and integrate space debris mitigation capabilities in these concepts in category 1. So you can see already the synergies. And having a system engineering approach and thought about it would really help you, and I think you do have it. So when you're writing your proposal, I think that's extremely important. Why? Because when we are selecting in step 2 the projects, we have to take a balance between the 3 categories. So we will not choose only projects in category 1 or only in category 2 or in category 3. We will choose projects which cover the 3 categories and they're well balanced, okay? We will also choose projects which will have a shared component, at least in 1 or more of the categories. They could have even a shared component among the 3 categories. But I always recommend to have a balanced focus. So not to say we can do everything or we can do only one thing, to try to find the right balance. Or complementarities among the components in different categories. So these are important aspects which you should think, because in the end of the day, the selected projects, they would work together. In the strategic plan, in the portfolio consideration, that's one of the major areas, creating synergies and complementarities so the projects can work together. And Celia can tell you during the evaluations when we were performing in step 2, that was one of the, we were looking at the system engineering point of view, at a helicopter and seeing which project and how can they benefit from each other and work together. So that's very important. And then, yes, this is very ambitious, extremely ambitious. Protection of EU space infrastructure, all debris sizes. I believe that the smallest debris are the most dangerous ones, and you know very well too. All orbits, because yes, now from 600 to 800 kilometers, as we can see, are the most polluted ones, but I personally believe that very soon there will be other orbits which will also become quite polluted. So, and again, cooperative and non-cooperative. So please be brave. What are the expected impact outcomes? This you can read pretty much, in the annual work program. For me, whatever concept you propose, it has to be, compact, affordable, but it has to be safe. It shouldn't create additional debris. So when we will be doing, that is very, very important. It needs to use less propellant, very little propellant, fuel efficient, and it has to bring some cost savings. For example, you can generate cost savings from in-space recycling or augmentation, think of different areas. And then the last thing which I truly recommend you when you're writing your proposals, please think about your portfolio activities. Some proposals don't add it, others do. Some have a work package, others don't. It is your own choice and freedom. However, the portfolio activities secures a separate budget line in your project where you can use this budget line for example, analysis which you would like to perform on the barriers or the upcoming opportunities. And this you can read in the challenge guide. So, for example, you want to compare the performance of different active debris or propellantless concepts. So, or in-space recycling ones, or you want to understand the drawbacks, the advantages or the drawbacks, you can use this as portfolio. Or, for example, on the regulatory ones, you will be looking at gaps on the regulatory framework, especially in space debris. That's a critical aspect with the new space law coming. But another aspect which for me is very important are the ESS flight qualification. If you're going to be launching hardware, you need to be flight qualifying and you need to have access to test facility. You can use part of that budget for that. And look, we also have here with our partnership from our colleagues from DG DEFIS, Pillar 2, Fast Track IOD, IOV, in case you have already hardware ready to be flown. Also, something which is new is the transition of technology to innovation, or it's where you can start thinking of performing early cost benefit analysis. And I think some of you already have seen a report from NASA from reusing and the cost and benefits of reusing space debris. It's one of the documents in the Space Challenge as a reference. But I think it's important already to think about early cost benefit analysis for certain technology, if you want, of course, or thinking about early market entry or early stakeholders you want to identify, or early commercialization, I call it. And communication and dissemination. There are also 50K booster grants for additional innovations to support you, but then maybe Celia later on will expand on that. So here is the work program. This is the challenge guide. Please do read the challenge guide. This is the document you need to read. Read it. And use it, especially that table with the 3 categories. That should be your reference table. The deadline is the 16th of October 2024. So what I suggest is that now you ask me a few questions, and then we start with the pitching session. So let's have maybe 15 or 20 minutes if you have any questions. Also to me, to Celia, or to Martin. And the long-term future. This is what I see in the long term. For me, it's very important that we have to be ready for long-term exploration, but we may have to secure that Earth orbits still remain usable and we don't lose the opportunity with the space debris. So thank you very much.